Yeah, good day, guys. Um, this a quick video. We'll be talking about the sensory cortex. Okay. Um, so now let's talk about the sensory cortical areas. And this is MBS Niger. Do subscribe to our YouTube channel if you haven't. The cortical areas associated with what processing what somatic sensory information collectively form what the somatosensory cortex. Okay. Now, the primary somatosensory cortical areas are what the S1 and the S2. There are minimum of 4 distinct areas in the cortex that receive what somatosensory inputs. Okay. The primary somatosensory area, that's the S1. The S1 is present in the post-central gyrus. Okay. The S1 includes the Brodmann's area 3, 1, and 2. Area 3 has sub-areas as the 3A and the 3B. How about the primary somatosensory area 2? The primary somatosensory area 2 is located in the wall of the Sylvian fissure. Okay. The somatosensory association cortex, that's the Brodmann's area 5. This is present in the posterior parietal lobe. Okay. It is called higher somatosensory cortex. Okay. It receives inputs from the S1 and the S2. Then how about the supplementary sensory area? This is part of the posterior parietal association area, okay, located on the medial wall of the parietal lobe. Okay, premotor supplementary area, primary cortex, central sulcus, primary somatosensory, and so on. And we also have other somatosensory areas. Okay, these include precentral gyrus, that's area 4. Though this is a primary motor cortex, it also receives somatosensory signals. Okay, and also cortical areas surrounding the S2. The cells in this area also respond to the somatosensory stimuli. Okay, now the S1, S2, area 5, and supplementary sensory areas project to the precentral gyrus. Okay, that's the area 4 and 6. That is involved in regulation of movement. Now, this provides an opportunity in the CNS for sensory motor coordination. Now, both S1 and S2 also receive monoaminergic inputs from the brainstem nuclei, okay, especially from the locus coeruleus and the raphe nuclei. Now, these sensory cortical areas are extensively connected to each other. Okay, you can see the connections. All right. S1 to S2, S2 to S1, thalamus to S1, S2 to thalamus, and so on. How about the outputs? We said that S1 projects mainly to the following thalamic and cortical areas. Okay, we have the ventral posterolateral nucleus of the thalamus. It projects to the supplementary sensory area. It projects to the S2. It projects to the area 5. It projects to the what? Area 4 and 6. You could see S1, all right, where it projects to the S2 here, and where it is projecting to the thalamic areas. Now let's talk about the somatosensory area 1. These are the Brodmann's area 3, 1, and 2. This is a primary somatosensory area that resides in the parietal lobe. Okay, inputs. It receives inputs from receives inputs mainly from the following thalamic cortical areas. Receives from the ventral posterolateral nucleus of thalamus. Receives from the S2 area. Receives from the brainstem nuclei. Okay. Okay, that's S1. S1 receives from what? The thalamic nuclei and the brainstem. Okay. Then the subregions based on modality specificity. The S1 is divided into the area 3, 1, and 2. Area 3 is subdivided into what? 3A and 3B. This division of S1 is based on their modality specificity. They respond either to cutaneous or deep stimuli. Okay. Now, area 3A and 2 respond mainly to deep stimulation. They respond poorly to cutaneous stimulation. Alright, how about area 1? They respond to both cutaneous and deep stimulation. How about area 3B? They respond mainly to cutaneous stimulation. Then topographic organization. The entire body is represented twice in S1, once in area 3B and again in area 1. Okay, the topographic representation is called sensory homunculus. Now, in this sensory map in the brain, the face is represented in the lateral part, hand and upper extremities represented in the dorsolateral part of the postcentral gyrus, and the lower extremity on the medial surface of the hemisphere. The greatest area of the map is devoted to the face, especially the lips, okay? That's area devoted to speech. And the hand, especially the digits, okay? That's cutaneous sensitizations from the areas involved in the skilled activity. The cortical receiving areas for trunk and back are small, okay? So now this is a nice image of the homunculus, okay? Hope you guys have seen that. You could see the wide area devoted to the lips, okay, because it's for speech, and the hand because they are constantly in use. For real, you speak to, all right? So you constantly use your speech to. Now, what is a columnar organization? In the S1, the neurons are arranged along a line perpendicular to the cortical surface, which is known as a columnar organization. The cortical columns are located adjacently, okay? Adjacently process different sensory modalities. What is the function? S1 is involved in the initial processing of somatosensory inputs. It also processes high sensory orders like perception of direction of an applied stimulus. How about the somatosensory area 2? The S2 is located in the superior wall of the Sylvian fissure. The topographic organization is such that head is represented at the inferior end of the postcentral gyrus and the feet at the bottom of the Sylvian fissure. Okay. Now the neurons of the S2 respond to light mechanical stimulation of the hair or skin. Okay, that's rapidly adapting mechanoceptors. They poorly respond to deep stimuli. How about the association cortex? The association sensory cortex is present in the parietal lobe. It receives inputs mainly from the S1, but also from S2 and the visual cortex. Its function is to coordinate the relations of the body to extra-personal space, okay? Hand-eye coordination. In the non-dominant hemisphere, the association cortex is involved in spatial relations, whereas in the dominant hemisphere, it is concerned with language. Okay, that's association areas, right? So I think these are the association areas. All right. Now, a lesion of the parietal association area of the non-dominant hemisphere produces impairment in the ability to respond to extrapersonal space. All right. That results in constructional apraxia and hemineglect syndrome. Okay. So with these guys, I think we did justice to central sensory cortex. All right, we also spoke about the various sensory cortex and the sensory cortical areas. Okay, so see you guys in the next tutorial, and bye for now. Do subscribe to our YouTube channel, check us on Facebook MBBS Niger, and like our page. Bye for now.